We have finally made it to Module 20, our last module in this series. And our last module, what we're going to see today, is that not every equation is linear and quadratic. I know we've been focusing on linears and quadratics, but those are only two equations out of very many in the math system. So we're going to look at another equation today, and it's called a rational equation. That word should sound familiar because we spent a whole bunch of modules talking about rational expressions. So let's go look at our notes for a minute. If you recall, the word rational has the word ratio in it, and the word ratio means a fraction. So today's equations will have fractions in them. Now, when I think about solving equations, I think about being a magician. Every different equation has its own different trick. We saw with quadratics that have the x squared. They have many tricks. You could factor them, you could square root them, you could use complete the square, you could do the formula. Well, today we're going to look at rational equations that have fractions, and we're going to learn how to get rid of the fractions. You never, ever, ever want to solve an equation with fractions. So let's go to the board. There are two different types of rational equations. Both of these equations, example 1 and 2 in your notes, are rational. They both contain fractions. The difference is the first example has one fraction on the left and one fraction on the right. This is a vocabulary word for middle school. When a fraction equals a fraction, you call this a proportion. So this equation that has fractions in it has a special name. It's called a proportion. This rational equation is not a proportion. It is not just one fraction on the left, because you can make 1 as a fraction by putting it 1 over 1. And it's not just one fraction on the right, because you can make x a fraction by putting it over 1. So this is not a proportion. So it's very important that when we're in rational world, fraction world, you look with an equation. This is called a proportion. One fraction equals one fraction. Now, believe it or not, you learned how to solve these in middle school. There's an easy trick to get rid of the fractions. To get rid of the fractions, you learn to cross multiply. Think about that. The reason why these are fractions is because they have the bar here. And that bar means what operation? Division. So to get rid of division, you have to do the opposite, which is multiplication. So on both these equations, we're going to learn the magic trick. To get rid of fractions, you multiply. When it's a proportion, all you do is cross multiply. You make these loops. It doesn't matter which loop you multiply first. I personally would multiply the loop with the variable first. So what is x times 15? Oh, that's 15x. Then you bring down the equals and you do the other loop. What's 10 times 48? 480. By cross multiplying, there is no more fraction, there is no more fraction. And there you are back to a simple linear equation. So now how do you get the x by itself? You divide by 15. We know that 15 over 15 is 1. We don't write 1x, we write x. 15 can't go into 4. 15 goes into 48 3 times. That would be 45 with a remainder 3. 15 goes into 30 twice. And there's your solution. So if you have a rational equation that is a proportion, you could crisscross, cross multiply. Now look at me. You can't reduce. You can't reduce 10 and 48 because that equals is like a wall. It's separating the left and the right side. All you're doing is crisscrossing, multiplying to get rid of the fraction. It's a trick. If you go to this rational equation, example 2, because it's not a proportion, because there are two fractions on the left and two fractions on the right, we're going to get rid of the fractions. We're going to multiply, but to multiply, we're going to need our LCD. Wow, that should sound familiar. Now think about it. The reason why this is a fraction is because you're dividing by 8. So common sense says the opposite would be to multiply by 8. The reason why this is a fraction is you're dividing by 6. So common sense says I would multiply by 6. But wait a minute. You can't take the left side and multiply by 8 and take the right side and multiply by 6. You wouldn't be balanced. That would be like me baking chocolate chip cookies. And if I decide to triple the recipe, only triple the eggs. No, you'd have to triple all the ingredients. So the problem here is because we can't crisscross, it can't cross multiply, it's not a proportion. The only way to get rid of the fractions is the least common denominator. So here we go. What's the least common denominator of 8 and 6? No, it's not 48. You don't multiply these. What's the smallest number they have in common on their times tables? It's 24. What you do with this 24 is you multiply it to all the terms. 1, 2, 3, 4. Why do you multiply it to everybody? To keep balance. Just like making a recipe. If I triple the eggs, I triple everybody. So everybody look. I'm going to multiply each of these terms by 4. Now this is important. This relates what we've been learning all semester. This is red. 24 times 5x divided by 8. Do we have to multiply the 24 times 5 first and then divide by 8? Or can we divide first? Well, if you know your order of operations, you know multiply and division are equal. It doesn't matter which one you do first. So what we're going to do is make this easy. We're going to divide first. 5 didn't divide into 8. That's why we had a fraction. 8 divides into 24, though, 3 times. So you're left with 3 parentheses 5x. Do you see a fraction anymore? No. Now we're going to come over here. The denominator is 1. Is dividing 1 into 24 going to change it? No. So we just have plus 24 times 1 equals, we don't need to divide 1 into 24. It's not going to change it. So we're left with 24 times x. Over here, we bring down the minus. 24 can divide by 6. That would be 4. So we're left with 4 times 1. That's the trick, guys. We got rid of the fractions by multiplying by a number that would go into everybody. So that's why we had to learn all about the LCD modules and modules ago. So now look, we're going to get rid of parentheses. 3 times 5x is 15x. 24 times 1 is 24. 24 times x is 24x. Negative 4 times 1 is negative 4. Then you would say to yourself, is this linear or quadratic? Oh yeah, it's a linear equation. It has x's to the first power. So to solve a linear equation, we move the variables to the left, we move the numbers to the right. So Ms. Black's going to subtract 24x, keep balance. 15x minus 24x is negative 9x. Bring down my plus 24. These are additive inverses. We're adding the opposite. They cancel out. Minus 4. Now we'll move the numbers. We'll subtract 24 from both sides of the equation. An equation only has 2 sides. Bring down the negative 9x. The additive inverses cancel. They make 0. Negative 4 and negative 24 is negative 28. We're not done yet. X is not by itself. We got to divide because it's the opposite of multiplying. So the opposite of multiplying by negative 9 is dividing by negative 9. A negative divided by a negative makes a positive. We don't need to write 1. We just write x. Now, we've discussed this many times. You cannot leave a negative in the denominator of a fraction. The negative floats to the top. If you float this negative to the top, 2 negatives make a what? A positive. So this is 28 over 9, which is an improper fraction. Those are allowed in higher math. Do not make that into a mixed number. They're not allowed. If this divided nicely in a calculator and gave you a decimal that stopped, it would be acceptable. But it's not going to. So we'd much rather you leave the solution as an improper fraction. So let me step back and look at this. In this section, 14.5, we are learning how to solve a rational equation. What's the word rational mean? It has fractions. To solve an equation that has fractions, your first step is to get rid of them. We don't like them. I'm with you. I don't like fractions. Get rid of them. But you got to understand how you do that. Fractions are fractions because of a division bar. So to wipe out division, you have to do the opposite, which is multiplication. If the equation only has one fraction on the left and one fraction on the right, it's called a proportion. To get rid of the fractions, you can do the crisscross, cross multiplying. If it's not a proportion, then you're going to have to multiply by the LCD. Let's try one more example. Okay? Let's look at your notes at example 5. Let's just try one more to make sure you got it. Okay. Example 5, the equation is 2 plus 4 over x minus 4 equals x over x minus 4. Okay, let's talk. Is that an equation? Sure it is. It has an equal sign. What kind of equation is it? Well, if you look, it's got a fraction bar. It's got a fraction bar. This is a rational equation. So the first thing you know you got to do is get rid of the fractions. You can't move anybody. Don't move fractions. Get rid of them. So you have a decision to make. Is this a proportion where you can cross multiply, or do you need the LCD? So if you look, you could write 2 as a fraction by 2 over 1. There's 2 fractions on the left. It's not a proportion. Do not be silly and tell me, well, 2 plus 4 is 6. Because we learned in previous modules, you can't add because you need a common what? Denominator. Don't even do that work. We don't want to add these and make one fraction. We're just going to wipe the fractions out. So what we need here is the least common denominator. Well, we don't got to worry about that because it's a 1. This denominator has an x minus 4. This denominator has an x minus 4. That would be like me asking you guys, what's the common denominator of 1/2 and 1/2? Well, they're already the same. The denominator would be 2. So the common denominator, x minus 4 and x minus 4, is x minus 4. Common sense. I want to get rid of fractions. Fractions mean division. So Miss Black said we're going to do the opposite. We're going to multiply. So I'm going to put an x minus 4 in every numerator. Why does it go in the numerator? Because if you wrote that as a fraction, it would be over 1. So that's why when we put the least common denominator, it goes in the numerator. You can't take x minus 4 and divide it by 1 because it stay the same. So you're left here with x minus 4 times 2. And you all know the 2 would go in front, knowing your order of operations. Plus this x minus 4 and this x minus 4 are the same. So there's a bar between them. That bar means to do what operation? Division. So that would divide out and leave 4. Same thing here. That x minus 4 in the numerator and that x minus 4 in the denominator are exactly the same. When you divide the same thing out, it cancels. Now everybody look, there's no more fractions. So now you're back to, is this linear or is this quadratic? Well, if you look, it's x to the first, it's linear. So we distribute to get rid of our parentheses. We could collect like terms on the left side because they're put together, they're numbers. So negative 8 plus 4 is negative 4. Now, my rule of thumb is when you solve a linear equation, x is moved to the left, numbers move to the right. So to move the x by subtracting it, 2x minus 1x is 1x. These are going to cancel, but you can't leave a side of an equation blank. It's got to be filled. It's got to balance. So x minus x is 0. So then we'd add 4, and there's your solution. Now, you're not going to like this. Here's the difference between Algebra 1 and higher algebra. You could go through the procedure beautifully. You did every step. This is gorgeous. You got an answer. No longer are you guaranteed this answer will work. So one of the things you're going to learn is once you start solving more difficult equations, every time you solve a rational equation, because you changed it and wiped out the fractions in the first step, there's no guarantee this will work. So what you're going to learn is every time you solve, you're going to have to do a what? A check. How do you check? You write the original equation I gave you. There it is, the original. You're going to replace x, substitute it for x, what number? 4. So we're going to leave 2 plus 4 over. Up there's an x, a 4 goes in its spot. There's an x, a 4 goes in its spot. There's an x, a 4 goes in its spot. Now remember, the whole goal in checking is to get a number on the left and a number on the right, and they should be the same. 2 plus 4. What's 4 minus 4? 0. What's 4 minus 4? 0. Well, guys, you should already notice that we have a huge problem. This is an arithmetic problem. In order to keep working this, you would have to do 4 divided by 0. If I have $4, explain to me how I divide that among 0 people. You can't. And we've discussed this back in previous modules. We've discussed this in Algebra 1. We've discussed this in arithmetic. You cannot divide by 0. If you type this in a calculator, 4 divided by 0, you will get an error. It doesn't exist. This is called undefined. Well, sweeties, you can't take the number 2 and add it to undefined. So the problem is you can't finish the check. You can't get one number on the left and one number on the right. I don't care if this is undefined. 2 plus undefined is not equal to undefined. It's not balanced. So if you get an undefined, that means you can't finish the check. And if you can't finish the check, that means this cannot be the answer. So like we talked about the other day, if this can't be the answer, we throw it in the garbage. It's useless. So here's our problem. I'm waiting for an answer. I have x equals, and it's blinking. It's waiting for something. If you have to throw that answer out, then you have no answer. And this is the only time in arithmetic or in algebra you could use the famous phrase, no solution. No solution means there is no number that will make your equation balance. There is a symbol for no solution. It is 0 with a line over it, with a line through it. That is not a 0 in math. That is the symbol for this phrase. You can only use this symbol when we're working an equation and the answer you get doesn't check. So that's the hard part about college math. You could solve the equation. It doesn't guarantee this answer is going to work. The only way you'll know if it works is you have to do a check. Okay, I'll catch you in the next module.